Good morning, dear students. Today we'll discuss the basic voltage regulator, which is consisting of the voltage reference VR, error amplifier, feedback network and series or shunt control elements. So types of the voltage regulators are, that is, series voltage regulator and shunt voltage regulators. So first we'll discuss the shunt voltage regulators. So this is a block diagram of shunt voltage regulator. The voltage regulator, the heart of the voltage regulator circuit is control element. This control element will control the entire system. So this control element is connected to the load in parallel. So it is called as shunt voltage regulator. The unregulated input voltage Vin, which will tries to provide the load current, but part of the current is drawn by the control element to maintain the constant voltage across the load. If there is any changes in the load voltage, the sample circuit will provides the feedback signal to the comparator, where the comparator will compare the feedback signals with the reference voltage, and it will decides the how much amount of the load of the current is required to be shunted to keep the load voltage is constant. For example, if the load voltage increases, then the comparator circuit decides the control signal based on the feedback signals, which draws the increased shunt current, that is ISH. Due to this, the load current IL will decreases. Hence, the load voltage decreases. So, this is regarding the block diagram of shunt voltage regulator. Next is series voltage regulator. The working principle is same for series voltage regulator, but the control element is connected in series with the load. So it is called as a series voltage regulator. Here also the same working principle is there. Sampling circuit will provide the feedback signals, which will send to the comparator circuit, where the comparator circuit will compare the feedback signals with the reference voltages, and it will decide the how much amount of current is required for the circuit to keep the load voltage as constant. So this is a block diagram of series voltage regulator. So next is comparison of shunt and series regulators. First is shunt regulator. Under the shunt regulator, as I said, the control element is connected to the load as a parallel. So it is called as a shunt regulator. So under the series regulator, the control element is connected in series with the load. So it is called as a series regulator. So only small current passes through the control element, which is required to be diverted to keep the output as constant. In the series regulator, the entire load current IL always passes through the control element. So third one is the control element is low current, high voltage rating components. But in the series regulator, the control element is high current, low voltage rating components. And the regulation is poor under the shunt regulator, and regulation is good under the series regulator. So efficiency depends on the load current in the shunt regulator. So efficiency depends on the output voltage in the series regulator. So this is not suitable for varying the load conditions, preferred for the fixed voltage applications. But for the series regulators, it will prefer the fixed as well as the variable voltage applications. So this is simple in design, and this is complicated in design. For example, shunt regulators, that is Zener shunt regulators and transistorized shunt regulators, etc. And for example, for series regulators are series feedback type of regulators, series regulators with pre-regulators and fold back limiting. So this is the comparison of shunt and series regulators. So next comes voltage follower regulator using op-amp. This is also nothing but fixed voltage series regulator. Here the op-amp is used as a comparator, where the op-amp supplies the derived from the input supply terminals. Hence the op-amp supply the voltage are V in, that is plus and ground. Then the inverting terminal of op-amp is connected to the output terminal. Therefore VB is equals to V naught. While the voltage is non-inverting terminal. So this is a non-inverting configuration. So the Zener voltage, that is Vz, that will decides the Va is equals to Vz. But due to the virtual ground, Vb is equals to Va. This we have seen in the non-inverting configuration. The series pass transistor, the Q1 is nothing but the series pass transistor which will supply the additional load where the op-amp cannot supply. So op-amp has to supply only the base current of transistor, that is IB. So this is IB. Next is, if the load current is less than 25 milliampere, then the series transistor, that is Q1, does not play any role and the op-amp behaves as a voltage follower. And the capacitor is large. In order, that is, we have to select the capacitor value as 50 to 100 microfarad. So the function of capacitor in this circuit is, it will help to supply the fast demands on regulator and it will eliminate the possibility of any oscillatory to behave of the regulator. So this is a voltage follower regulator using op-amp. This is also known as voltage series regulators. So next is performance parameters. So these are the equations are there. Please go through these equations. Based on these equations, we'll solve the problems in the next session. This is also the performance parameters equations. Based on these equations, we'll solve the problems. Thank you.